Okay, whether the screen is visible, everyone?
Yes, sir.
Yes, sir.
I will upload two solutions. One for this one. Okay, so this problem ka solution पे upload करते and another one ladder का problem. So virtual. So just concentrate. Work is nothing but the product of force into displacement is called as work. Okay, when do you say that work is done? Whenever the displacements are same. Okay, whenever there is a displacement, at that time you can feel that there is a work is done. If the displacement is not seen, okay, with the naked eye, then that is called as virtual. Okay. Okay, see, the work done by a system of forces acting on a body in equilibrium due to imaginary consistent displacement is called as virtual work. So consider this is a body. Okay, when this is a body, so when there is a force is acting on this one, so this force will produce a small displacement. The body is in equilibrium. So equilibrium means, is it in motion?
No, sir.
No, it means
No,
the
sir.
displacement, is it visible? The displacement is visible?
No, sir.
No.
No,
So the
sir.
displacement
No.
is not visible. It means the force is acting, but the displacement is not visible. It means however the force is, the displacement is very, very small. Okay. It means it cannot be seen with naked eye. In that case, the displacements are called as imaginary consistent displacement. If displacements are very small, then those displacements are called as imaginary consistent displacements. Then work done by the system of forces acting on a body in equilibrium. The body is in equilibrium due to the imaginary consistent displacement is called as virtual work. Okay, so work is equal to whatever force is applied, the system of force into your displacement. Okay, that is
Displacement.
your consistent imaginary displacement. The term virtual work means the displacement does not really exist. Virtual work means the displacement is not exist. It is very, very, very small. It is very minute. The displacement is only assumed to be exist. We have to assume that there is existence of displacement, so that we can compare the various possible equilibrium positions and determine the correct ones. Okay, just assume that in the virtual work, the displacement are imaginary. They are not visible. Okay. So principle of virtual work क्या बोलते देखो? If a system of forces acting on a body, when body is under equilibrium, it undergoes imaginary displacements. Then the total work done by all the forces must be zero. So consider this is a body. This body is subjected to F1. This is F2. This is F3. Okay, system of forces. This F1 force will produce a displacement D1, small d1. F2 force will produce small d2. F3 force will produce small d3. Then total work done is equal to total work done. Work done is equal to algebraic sum of this work done, this work done, this work done. That is F1 d1 plus F2 d2 plus F3 d3. Okay. This is what is called as principle of virtual work. If a system of forces are acting on a body in equilibrium, undergoes imaginary displacement. This important. This statement is important. Imaginary displacement. Then the total work done by all the forces must be zero. Is it clear? Principle?
Yes, sir.
So this is nothing. Okay. In order to explain this one, just I will come back to the plane. So now you should tell me. So it is in which system? Okay. There are two axes. Okay. When there are two axes, it is in plane or space. X and Y. It is
In plane.
in plane. Okay. It is in plane. Okay. The force is acting in this direction. The name of this force is F. It is theta. Okay. Can you tell me it is in plane? Okay. If it is acting only two axes, that is called as plane, or it is called as two dimension. Okay, so can you tell me x component fx?
Fx cos theta.
F cos theta. Can you tell me y component?
F sin
theta.
F sin theta.
Sin
Or else. So what I will write? So if it is theta x, so along x direction, fx f cos theta x. Is it okay?
Yes, sir.
Okay. So if I write this is theta y with respect to y, can I write fy is equal to f cos theta y? Is it okay?
Yes, sir.
Yes. Okay. Then how will you find out that it's resultant? Under root of fx square plus fy square.
Summation of.
Correct na? Okay. So if the forces are lies in a three-dimensional, if the forces are lies in three-dimensional, that is three axes. Okay. So the axis will be, so I will take this is z axis. Okay, this is z axis. Then the angle made by this force along with z axis, I will take it as theta z. Then x component, when the force act in a different planes, then they are called as forces in space. Then x component का value क्या हो जाएगा? F cos theta x. Then y component का force क्या हो गया? F cos theta y. Then z component का force क्या हो गया? F, this is F into, okay, F into cos theta z. So theta x is, F is making an angle alpha theta x along x direction. Theta y is, F is making angle theta y with respect to y direction. Theta z is nothing but F is making an angle theta z with respect to z direction. Then how will you find out the resultant force? R is equal to square root of and summation of sigma fx square plus summation of sigma fy square plus summation of sigma fz square. So I will write like this: R is equal to under root of summation of sigma fx square plus summation of sigma fy square plus summation of sigma fz square. Okay, so it is similar to your plane. So when it is in plane, there will be only fx and fy. Resultant is under root of fx square plus fy square. When it is in space, that is in three coordinates, then it is fx component, fy component, and fz component. Then resultant is equal to R is equal to under root of fx square plus fy square plus fz square. Okay, clear?
Yes.
Okay. So in the plane, in the two-dimensional, what is Rx? Rx is resultant along x direction. So Rx can be written as R cos theta. Correct, na?
Yes.
Everyone, correct?
Yes, sir.
Yes. So if I take theta is theta x, so can I write this cos theta x is equal to Rx by R?
Yes, sir.
Similarly, here he has taken cos theta x is equal to Rx by R. Cos theta y is equal to Ry by R. Cos theta z is equal to Rz by R. Okay, so it is not important, just he has taken. And what will be the equilibrium conditions? Sigma fx is equal to 0, sigma fy is equal to 0, sigma fz is equal to 0, and moment about a point is equal to 0. When it is in a plane, and non-concurrent, can you tell me what are the conditions? See, this question is asked in ISC. This question is asked in UT2 also. What are the equilibrium conditions for the non-concurrent plane system? Yeah.
Fy equal to 0.
Sigma
Fx is equal to 0,
Yeah.
Fy is equal to 0, and M is equal to 0. It is in two-dimensional, that is plane. If it is in space, then there is one more term, that is sigma fz is equal to 0. Sigma fz is equal to 0. It is in space. So now onwards, you have to be careful whether it is in plane or it is in space. If it is in space, then there is a term, another term, that is sigma fz is equal to 0. Is it clear, everyone?
Yes, sir.
Yes, sir.
Any doubt to anybody?
No, sir.
Okay, so this completes entire second chapter. Okay, so we have completed each and every part of your syllabus from the second unit. Okay, I will provide the solution of that ladder problem, okay, with handwritten notes in the telegram. That is one cable problem. Okay. Do you have any problem?
No, sir.
Okay. Is it visible? Full screen?
No.
Now, is it visible?
Yes,
Yes,
sir.
sir.
Yes. So now let's move on to the next chapter, that is analysis of pin jointed frame. Is it full screen visible?
Yes,
Yes.
sir.
Yes.
Yes. Okay.
Yes, sir.
So already you have written in the initially what is syllabus. In this syllabus, the total it is 6 hours chapter, and in the final exam it carries 12 marks. So in this chapter there is one problem in your final exam. Okay, if it is offline, if it was offline 100 marks me, so maximum there will be theory questions. There will be theory. See, 4 marks there is a theory, and 8 marks there was a problem. One problem. Pin jointed statically determined plane truss, perfect frames, assumptions, determination of nature and magnitude of forces in the member, simple trusses, zero force members. Okay, we will study each and also you have to study the analysis of trusses by method of joint and by method of section by graphical method. But this graphical method is not included, only by method of joint and by method of section is included in your exam also. So each and every part we will see. First of all, about the title of the chapter. So what is the chapter name? Chapter name is what? Analysis of pin jointed plane frame. First, you should understand what is analysis. Okay, in the beginning only I told. Okay, what is analysis means? To finding the unknown forces. Analysis मतलब finding the unknown forces. Design मतलब क्या है? Design मतलब to finding the dimensions. Okay, अभी एक slab है. Slab में कितना forces आ रहे, कितना loads आ रहे, that is nothing but analysis. For that loads, for that forces, how much depth I need to provide, that is nothing but your design. Okay, am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Analysis means study for finding out the result. Whatever result is coming, that we should analyze, that we should study, that we should find out. Okay, analysis means finding out the unknowns. Pin jointed मतलब क्या है? So means members are joined to each other by pin or hinge. Okay, so consider there is one member. Okay, and consider there is another member. I want to connect these two. So how to connect this one? Okay, so there is two methods. One is by method of bolt, by method of rivet. Okay, if you use one bolt and single bolt or single rivet, then that will become pin. Okay, so in the diagram it will show like this. So consider this is, I will take here on, this is one member. Okay, and I will consider this is another member. I have to join by these two with the help of the single rivet or single joint. Okay, so this is nothing but pinned. It means that these two members can be rotated but cannot go horizontal direction, cannot go vertical direction. The rotation may be possible. Okay, how will be, what are the reactions for the hinged support? If it is hinged or pinned,
Two.
what are the reactions? Two. What are those?
Two.
Horizontal and vertical. Is it moving in vertical direction? No, it means there is RY reaction. Is it moving horizontal direction? No, it means there is a horizontal reaction. Where it is not possible to move, that in that direction there is a reaction. See, this is one plate, this is another plate. These two plates are connected by single bolt or single rivet. In this case, you can rotate like this, but you cannot move, it cannot move in a horizontal direction and it cannot move in vertical direction. Okay, that is called as pin jointed. Pin joint means, so you consider this is one plate, this is one plate. ये दोनों प्लेट ऐसे ये करने का, फिट करने का, एक बोल्ट डालने का, that will mean you can rotate like this. Is it visible in the image video? Okay, you
Yes,
can
sir.
rotate the plate, but you cannot move in horizontal or move in vertical. So this is pin jointed. If I consider this plate, I will weld it. I will welding देखा है ना आपने? So
Yes, sir.
if you weld it, is it possible to move in horizontal direction? No, you
No,
cannot.
sir.
Is it possible to move in vertical direction? You cannot move. Is it
No.
possible to rotate होता है क्या एक बार weld
No,
करने के
sir.
बाद?
No, sir.
No, sir.
That is which type of joint? That is not a pin joint. That is rigid joint. That is rigid joint. Are you getting difference between the pin joint and rigid joint?
Yes.
Yes, sir.
Yes.
Yes, sir.
So now in this chapter we are studying purely pin jointed structure. When you come for the higher study, in that case you will study rigid jointed structure. Okay. Now what is plane frame? Plane means what? Plane means what? That is only
180.
that is x-axis and y-axis, xy plane or yz plane or zx plane. Only one plane is considered. Anything you can take, if it is possible to represent in that particular plane, then that is called as plane. If it is not possible to represent in a single plane, then that will become space frame. Okay, all two-dimensional figures are plane. All three-dimensional figures are space. Okay, see, plane frame means, it means a frame which all the members lie in a single plane is called as plane frame, or it is also called as two-dimensional. A frame in which all the members lie in single plane is called as plane frame. So overall, I have to define your all analysis of pin jointed plane frame. So how do you define overall analysis of pin jointed plane frame means it is the study of members lying in single plane joined by a pin for finding out the forces in them. Okay, there will be one truss. This truss is plane frame. Okay, plane frame. I have to find out the number of forces in this frame. Okay, by analysis. The study of members lying in a single plane joined by a pin for finding out the forces in them. This is called as analysis of pin jointed plane frame. सभी को ये टाइटल समझ में आ गया? What is analysis of pin jointed plane frame? मतलब
Yes, sir.
Yes, sir.
yes. So about the central idea of the chapter. So by studying this chapter, हमको क्या समझ में आते हैं? After studying entire this chapter, what is the central idea? What is the main motto of this chapter? Is in this chapter the term frame and its different types of frames are explained. What is frame and what are the types of different types of frames we will study. The analysis of pin jointed plane frames by using method of joints and method of sections are discussed in this chapter. Okay, there is one plane frame. So how to find out the number of forces, okay, in the each member is done by using method of joint and method of section. These two methods are there for a syllabus. By using these two methods, we can find out all the member forces. So after studying this chapter, after completing this chapter, the students can be able to find out. Okay, you can find outcomes. आपको क्या मिलेगा? You can understand the difference between truss and frame. What is truss? What is frame? आपको समझ में आएगा. To find out the forces in the members of a truss by using method of joints. Okay, by using method of joint, you can find out the forces in the member. And also to find out the forces in the members of a truss by using method of sections. Okay, you can differentiate, you can find the member forces by method of joint and by method of sections. So this is truss structure. See, the members are connected, end to end connected. This is pin connection. All the ends are pin connection. Pin, or it is also called as pin को और एक word क्या है? Hinged.
Hinged.
Yes, yes, very good. So all the ends are hinged. All the ends are pinned, including support. Okay, so this is not a hinged. Okay, this is fixed. Okay, this is frame structure. Okay, see, this is what the question was asked in the ISC and unit test. Correct, hai na? Conditions for equilibrium for non-concurrent force system. For non-concurrent force system, what are the conditions? Sigma fx is equal to 0, sigma fy is equal to 0, sigma m is equal to 0. Now, can you tell me what is the condition for the equilibrium of concurrent force system? Concurrent force system. Can you tell me?
Summation of fx is equal
Sigma
to
f is equal to 0.
sigma f y is equal
Summation
to
of
0.
y is equal to
R
0. And R is
summation of
That
r
is
is equal to 0.
R is equal to 0.
R is
Fx
equal
and
to
fy
0.
0 means R automatically equal to 0. Whether m is equal to 0 here?
No.
No,
It is not
No, sir.
necessary because all the forces are passing through the given point. Concurrent. It will not produce any moment. Okay. Types of support you have studied in the second chapter already. What are the different types of supports?
Simple roller, hinged and fixed.
roller, hinged or pinned up fixed support.
You have studied all these things. Okay. Simple support, roller support, hinged support. Okay. Fixed support. You have studied all these things. Correct, Ina?
Yes, sir.
Yes, sir.
You have studied different types of loading also. Okay, now this is the point. I need to start. What is pin jointed plane frame? Okay, so first of all, what is pin jointed? Pin jointed frame is a structure made up of slender members. It is a structure which is made up of slender members pin connected at the ends and capable of taking the loads at the joints. See, this is one structure. The members are slender. Slender means the one dimension is very long as compared to its cross section. Length is very large as compared to its cross section. That is called as slender member. So this is slender, this is slender, this is slender. Okay, and the ends are connected. This is end to end is connected. So this is one member, this is one member connected. This is member and this member is connected. Here the end to end is connected. Which type of connection this is?
Pin.
Pin connection. Yes, good, pin connection. Okay, what is pin jointed frame means? It is a structure made up of slender members. Pin connected at the ends and capable of taking the loads at the joint. So wherever there is a joint, in that case, the loads are acting. So always the load is acting at the joint only, at the nodes. Okay, so you can consider the load always act at the joint. Then slender members means a member whose cross-sectional dimensions are quite small as compared to their length. इधर मैंने बोल दिया ना, length is very large as compared to its cross-sectional dimensions. Such frames are used as roof trusses to support the sloping roof and used as bridge trusses. So अपने वर्कशॉप में वगैरह देखा होगा. So ऐसे एक ट्रसेस रहते हैं, देखो, ऐसे एक ट्रसेस रहते हैं. The members are like this inclined. Okay, the members are like this. इसके ऊपर क्या शीट प्रोवाइड करते हैं, नहीं तो ये टाइल्स रहता है ना, मंगलोर टाइल बोल के, टाइल्स विल बी प्रोवाइडेड.
Yes, sir.
ऐसे रूफ देखा है ना, ऐसे रूफ.
Yes.
Okay, this member wooden member भी रहते, बाद में स्टील का भी रहते. This is called as truss, roof truss, and bridge trusses are example for the plain members. The frames are used as arms of many machines. See in this diagram. So there is an arm. So here also the member is connected, end to end connected. So this is also a plane frame. Then plane frame of truss. A frame in which all the members lie in a single plane is called as plane frame. Okay, so when you consider this is, so all the members are in x and y direction. So this is y direction, this is x direction. Okay, all the members are lying in one plane. Okay, this is called as two-dimensional figure, or you can also call it as it is plane frame. So plane frames are called as two-dimensional frames. They are designed to resist the forces acting in the plane of a frame. So these are designed to resist the forces which are in plane forces. Okay, so always these can resist only in plane forces. Roof trusses and bridge trusses are example for the plane trusses. Example for the plane trusses are roof trusses and bridge trusses. Okay, space. Okay, now you have seen what is plane means two-dimensional. Correct? No? Space means
Three-dimensional.
three-dimensional. So space frame means a frame in which all the members of a frame do not lie in a single plane is called as space frame. Okay, if it is possible to, if it is lying in a single plane, then it is called as plane frame. If it is not possible to represent in a single plane, then that is called as space frame. Example, tripod stand, transmission tower, observation towers are example for space frame. See, this is tripod. Okay, this is when you come for the surveying chapter in your basic civil, also there is a surveying, and also when you come for the higher study in civil engineering, there is a tripod. Okay, over this the machine is established or mounted. This is called example for the three-dimensional. See, there is a three legs. Is it possible to denote in a two-dimension? Because
No,
all
sir.
are different.
Yes, sir.
See here, there is one leg, there is another. So in order to show this one, you should have a three-dimension. This is transmission tower. Will you represent in a two-dimension? No, it is not possible. It is
No, sir.
three-dimensional. So this is a roof, that is a dome, okay, shell. So in order to represent this one, you have to represent in 3D. Okay, the members which do not lie in a single plane is called as space frame. These are the examples for the space frame. Then some of the important terminologies. If all the members of a rigid frame are constructed by the frictionless pins to form triangles, then it is known as truss. Okay, what is truss is nothing but if the members are of a rigid frame are constructed by frictionless pins. So this is one member, this is one member. This end-to-end connection is, it is frictionless joint. Frictionless, there is no friction. It means the movement is there. Okay, so then this is called as truss. This is called as truss. Triangle is the simple geometrical figure which is rigid and stable for external load. So the minimum, the perfect, the simple geometrical figure is triangle. So this is one triangle. If you apply the load, it will not collapse. Okay, this is the perfect geometry for the truss. You can increase, but you cannot decrease. Okay, if you provide only two members, it will not carry any loads. If you provide three members, yes, it will carry the three members loads. So here, these are one important terminology. These are M. M is number of members and J is the joint or it is number of joints. So these ends are denoted as joints, and these are M. This is one member. This is one member. This is one member. Okay. Okay. Before going for the next point, so you have to write some point. Okay. So ऐसे मैंने explain करके जाएगा है तो आप थोड़ा लिखने का है. Okay. So all of you read the unit number 3. Write in your notebook. I will give some point.
सर
हाँ.
अगर हम प्लेन से जा रहे हैं तो प्लेन के लिए एयर फ्रिक्शन होगा ना सर, उसका अपोजिंग फोर्स होगा ना सर, उससे एयर हवा
Air.
हवा सर प्लेन को
हाँ.
हाँ अपोज करेगा ना सर आगे जाते हो, तो फिर उसका फ्रिक्शन होगा क्या सर, उसका कुछ फ्रिक्शन आएगा क्या उसका?
See, the friction between the air and the material is very, very, very small as compared to the friction between the one material to another material. Okay. It
Okay.
is very, very, very less and it is neglected. And also in the analysis of the plane frames, pin jointed structure, the self weight of the material is also neglected.
Neglected, sir, yes.
Neglected. Okay. So all of you read this one. Analysis of pin jointed plane frames. Analysis of pin jointed plane frame. Will you write all these points or only you will write direct this point? Last point. What will you do? I will upload this PPT anyway. Okay. Just you write final definition. Okay. You can read all these things. Is it okay? Final definition like that?
Yes, sir.
Okay. Write down the final definition. Analysis of pin jointed plane frame. Analysis of pin jointed plane frame means the study of members lying in a single plane, joined by a pin, for finding out the forces in them. Have you written?
Yes, sir.
Okay. This is not necessary. You know all these things. Okay. What is important? I will do that. You know you will write all these points. Okay. You can write this one. Pin jointed plane frame. Pin jointed plane frame. Pin jointed plane frame. A pin jointed frame is a structure made up of slender members pin connected at the ends and capable of taking loads taking loads at the joints. At the joints. Next point. Slender member means a member whose cross-sectional dimensions are quite as compared to their length. Such a frames are used as roof trusses to support the sloping roofs and used as bridge trusses. The frames are used as arms of many machine. Have you written?
Yes, sir.
Yes, sir.
Written. Plane frame or truss. A frame in which all the members lies in a single plane. A frame in which all the members lies in a single plane is called as plane frame. Let's write on this point. Roof trusses and bridge trusses. Roof trusses and bridge trusses are examples of plane frames or trusses. Roof trusses and bridge trusses. Okay. You can draw this diagram also. Okay. So how to draw this diagram? Sure. Draw like this. This is one line. Okay. You can connect. This is one connection. This is one connection. Like this you have to draw. Draw like this. And if you want to show, you can make a thick nose. It means this is pin connected, pin jointed. Okay. Like this you can draw. So this is the example. So the same figure I have drawn like this. Have you taken?
Yes.
No, sir. 1 minute.
Okay. The same figure I can draw, like you can draw like this. Okay. I say this is in a zoom figure, no? That's why it is shown like this.
Complete, sir.
So space frame. Next point is space frame. Write on the definition. A frame in which all the members of a frame do not lie in a single plane is called as space frame. Full stop. Example, tripod stand, comma, transmission towers, and observation towers. Okay, full stop. It is not necessary to draw the diagram. Okay, आपको चाहिए तो ऐसे लिख सकते हैं, नहीं तो you can draw this diagram, tripod stand. So tripod stand you can draw. Like this, you can draw the tripod stand. Okay. So you can write it. This is tripod stand. This is tripod stand. Tripod stand. You can draw this mesh also. Okay, it is not possible to draw. Okay. Just you draw. You have written already examples. Okay, that is sufficient. In exam में examples पूछते हैं. Okay, diagram नहीं पूछते. Is it over?
Yes.
Okay, terminology you don't write it. This one I will give later. Okay, so you have seen what is truss, what are the plane frame, space frame. Okay, so I have told in the last class, that is in the last chapter, there are two types of beams. One is determinate beam and one more is next one more is indeterminate.
Indeterminate.
Can you tell me what is determinate beam? Determinate beam मतलब क्या है? So what are unknowns? Support reactions are unknowns. Correct? So if equilibrium equations are sufficient to find out the unknown support reactions, then such a beam is called as determinate beams. If the equilibrium equations are not sufficient in order to find the support reactions, then such a beam is called as indeterminate beams. Similarly, in the frames also, there are two types of frames. One is statically determinate frames. So same concept. A frame is said to be statically determinate if it is completely analyzed by using conditions of static equilibrium. Then this frame is called as determinate frame. Okay, if the entire frame, the number of members, forces in the, if you are finding the member forces by using the equilibrium conditions only, then such a frame is called as statically determined frame. If it is not possible with the help of equilibrium conditions, then such a frame is called as indeterminate frames. Statically indeterminate frame. So what is this one? A frame is said to be statically indeterminate. This is what is important, indeterminate. Indeterminate when if it is not completely analyzed by using the conditions of static equilibrium. Static equilibrium. Okay. So if the frame is analyzed by taking only equilibrium conditions, then such a frame is called as
Determinant.
determinate frame. If the frame is analyzed not completely with the help of equilibrium equations, then such a frame is called as
Indeterminate frame.
indeterminate frame.
Determinant.
So for the perfect example for a statically determinate frame is perfect frame. You will study what is perfect frame. For indeterminate frame, it is redundant frame. Okay. So now we will see what is perfect and not. See, so pinjointed frame. So now whatever you are studying, pinjointed frame. Here there are two types. One is determinate frame and another one is indeterminate frame. Okay, you have seen what is determinate? What is determinate?
With the analysis with the help of equilibrium.
Yes, complete analysis is done with the help of equilibrium equations. Here, complete analysis is not possible with the help of only equilibrium equations. Okay, that is called as indeterminate. So, perfect frame. So, if m is equal to j is a condition, m is equal to 2j minus 3, then that is called as perfect frame. If m is not equal to 2j minus 3, then that is called as imperfect frame. Okay, I will draw one frame. So this is one frame. So how many members are there? Members. This is one, this is two, this is three.
Three.
How many joints are there? Joints. This is
Three
one,
joints.
this is
Three.
two, this is joints are three. Okay, three. So apply this one. M is equal to 3. Okay, 2 times of joints. How many joints? 3 joints.
Three joints.
Minus how 3. So 2 into 3, 6.
Three.
6 minus 3,
Three.
3. So 3 is equal to 3 are there. So it means is it perfect or not imperfect?
Perfect.
It is
Perfect.
perfect. Okay, it is perfect. So if the frame satisfy the equation m is equal to 2j minus 3, then such a frames are called as perfect frame. If the frame does not satisfy the condition m is equal to 2j minus 3, then such a frames are called as imperfect frames. Okay, so in this also imperfect, there are two types. One is if m is less than 2j minus 3 and m is greater than 2j minus 3. If m is less than 2j minus 3, then that is called as deficient frames. If the m is more than 2j minus 3, then that is called as redundant frames. Okay, what is m? Number of members in a truss. Then what is j? J is equal to number of
Number
joints.
of joints in
Number
truss.
of joints in the truss. Okay, so you should remember this figure. What is pin jointed? Again, there are classification is two types: determinate and indeterminate. In the determinate, again two types. One is perfect frame, another one is imperfect frame. Perfect frame means m is equal to 2j minus 3 condition. Imperfect means m is not equal to 2j minus 3 condition. So deficient means members are less. Deficient means what? Less. Na? So m is
Yes,
less.
sir.
Members are less than 2j minus 3. So that is deficient. If members are more, I to redundant. M is more than 2j minus 3. Okay, I will draw one frame. You have to tell me, is it perfect or deficient or redundant? So like this. Okay. Is it visible, everyone?
Yes, sir.
Yes.
Okay. How many members are there? This is one member, 2, 3, 4, inclined member 5, inclined member 5, 6. There are 6 members are there. Okay. Then how many joints are there? How many joints? See, joints are like thick. Okay. These are joints. How many joints? this in between is not a joint. It is
Five.
not made. No, it is not a joint. Only 4 joints are
Yes,
there.
not joint.
Only
Yes.
4 joints are.
Only four
हाँ,
joints.
so now m is equal to 2j minus 3. m is 6 आ गया. m is equal to 6. 2j minus 3. 2j minus 3. So 2 into joints are how many?
4.
4. 4 minus 3. So 2 into 4, 8. 8 minus 3, 5. Okay.
5.
It means m is equal to 6 आ गया. 2j minus 3 is equal to 5 आ गया. So m is greater than 2j minus 3. 2j minus 3. Yes or no?
Yes, sir.
Yes.
M is equal to 6i. 2j minus 3 is equal to 5.
Redundant आया sir.
So it is redundant.
Redundant.
Means
Redundant
extra
frame.
हो गया. Extra हो गया. So एक कितना extra है वो कितना है? एक member
One.
extra है. One member is excess. That's why it is called as redundant frame.
Redundant frame.
If you take one more,
Redundant.
if you take like this,
Redundant.
if you take, how many members are there? How many
Five.
members? 5 members.
Five.
M is equal to 5. How many joints are there?
Four.
4. M is,
Four.
J is equal to 4. So M is equal to 5 and J is equal to 4. 2J minus 3. 2J minus 3 कितना हो गया?
5.
2J. 2 into 4 is 8. 8 minus 3 is equal to 5.
8
So
minus
M is equal to
5.
2J minus 3 आ गया. Is it perfect or imperfect?
Perfect.
Perfect frame. So again, one more. Okay, I will draw like this. Okay, one more diagram I will take. Now, okay, you have to tell me.
It's a deficient.
Deficient. Yes, good. How many members are there? M is equal to 4.
4.
Joints are how many joints? 4.
0.
Joints are also 4. Okay, now
Yes.
M is equal to 2J minus 3. 2J minus 3. So 2 times of joint. 4 into 2, it is 8. 8 minus 3. 8 minus 3.
5.
5.
5.
How many members are there? 4 members. So M is less than 5. It means members are combined. So this is deficient. This is deficient. So see, example I have taken for this case perfect truss. This is the perfect truss. Okay, this is perfect truss. So for deficient, it is deficient. Members are less high. This is deficient. For redundant, members are more. Members are more. Okay, members are more. Okay, in one figure, I have shown perfect frame, I have shown deficient frame, I have shown redundant frame also. Is it clear, everyone?
Yes.
Yes, sir.
Yes.
So it's the same thing. Whatever I have given in the pictorial diagram here, the same thing is explained here. So what he has explained, just check it. So he has given the definition. Perfect frame means what? A pinjointed frame which contain just sufficient number of members to resist the load without any appreciable deformation in shape is called as perfect frame. A perfect frame has to satisfy the following condition. So condition is M is equal to 2J minus 3, where M is the number of members, J is the number of joint. This is perfect triangle. Okay, triangle is the perfect frame. How many members are there? 3. Correct?
3.
3 members.
Yes.
How many joints are there? How many
Three.
joints?
3 joint.
3 joints. J is equal to 3. So 2J minus 3. 2J minus 3 karo. 2 into 3 is 6. 6 minus 3 is equal to 3. So M is equal to 2J minus 3. It is holding. So this is perfect frame. Okay. Next. Deficient frame. What is deficient frame? So a frame is said to be deficient if the number of members are in it are less than the number of required for a perfect frame. So perfect frame को कितना चाहिए था ना members, उससे कम है तो that is called as deficient frame. These frames cannot retain their shape when loaded for a deficient frame. When you apply the load here, it will not remain its shape. The shape is going to change. It has to satisfy the following condition. So M is less than 2J minus 3 for deficient. Okay, this figure I have shown. This is less. M is equal to 4 hai. 2J minus 5 is equal to 5 hai. Okay, this is deficient.
Yes, sir.
Then redundant means excess. A frame is said to be redundant if the number of members in it are more than that of the required for a perfect frame. Perfect frame को कितना चाहिए था? उससे ज़्यादा आए तो that is called as redundant frame. Such a frame cannot be analyzed by using equations of equilibrium. Those are called as indeterminate frames. So redundant frames is statically indeterminate frame. For redundant frames, it has to satisfy the following conditions. That is, m is more than 2j minus 3. Okay, this one member is excess away. That is redundant frame. Okay, so summary is this is perfect frame, this is deficient frame, this is redundant frame. Is it clear, everyone?
Yes.
Okay.
Yes, sir.
Yes, sir.
So this assumption we will take in the next class.
सर पिन जॉइंट में हमारे डिवाइडर आएगा क्या सर?
Yes, correct. Very good point. Divider is the example for the pin joint. See, उसमें कितना जो bolt एक ही bolt है ना?
एक ही रहता है सर.
Yes,
Yes, sir.
yes. That so you can rotate like this. Correct na? You cannot move.
Yes, sir.
That is the best example for your pin jointed. Okay, I will just a minute. 57 students are present. 13 absent. 16. 19. 32. Okay, present. 31. 49. 58. Okay, absent numbers 13, 16, 19, 37, 49, 58. Okay, so these are the absent numbers. 43 is present. Okay, so we'll stop now. We'll continue in the next class. Okay. Yes,
Yes.
everyone.
Okay. Yes,
Okay,
sir.
okay, okay. Bye.
Yes.
Bye, sir.